Alright, so in the section we just got done, we were looking at bonds between molecules, or between atoms. Right, and we said that there were three major types. Whoops, there we go. We said that we had ionic bonds, which were between a metal and a nonmetal. We said we had covalent bonds, which were between two nonmetals, and that we had a metallic bond, which were between two metals. Well, to do this, we have to then know what our metals and nonmetals are. Not too hard to do that. We just remember we had our line right here. And just for simplicity, everything over here is a nonmetal, and hydrogen also fits in that nonmetal group, and everything else is a metal. Okay? We are going to go one step farther, though, and we're going to break up this covalent into two different categories. And it is nonpolar covalent and polar covalent. And again, we want to keep this as simple as possible, so our definitions for these are going to be: if it is nonpolar covalent, it is two nonmetals of the same type. So if I have oxygen bonded to oxygen, right, they're both the same atom, the same element, we can, this would be a nonpolar covalent. If I had fluorine bound to fluorine or hydrogen bound to hydrogen, any two nonmetals, same type, bonded together, we're going to call nonpolar. The only exception to this is if hydrogen and carbon bond, we will call that nonpolar as well. Okay, so that's my one exception, so make sure that you know that one exception. Okay, so then if you have two nonmetals which are not the same, we will call that polar covalent. And the reason for this distinction is where the electrons are. In nonpolar covalent, I have hydrogen, my two electrons are right in the middle. Each of them pull on the electrons the exact same amount. So neither one of them can win. So my electrons will be right in the middle most of the time. If I put hydrogen with oxygen, however, oxygen is much, much, much stronger. It's much more electronegative, so my electrons end up being closer to my oxygen. Okay? Which we need to know this when we get into molecules, because that has a very big effect on what the molecules do. So let's draw out a couple of molecules here and look at that. If I have something like this, this oxygen is much, much stronger than all of the rest of these atoms in here. Okay, and so it pulls all the electrons towards it, which means that right here on the oxygen I have a high density of electrons, and so it is partially negative. So whatever atom is the most electronegative, give it a partial negative, and that's what this little sign is. That D with a tail there on the top is a delta, and it means partially. And then here we would say that it is partially negative. So, and then everything else that isn't partially negative, we would say is partially positive. All right. So the way that we're going to determine whether it has a partial negative, partial positive or not is symmetry. Okay, so we are going to look at our molecule. If it is perfectly symmetric, it will be nonpolar. If it is asymmetric, it will be polar. Okay, it will have something that's pulling harder than everything else. And you can just remember that by remembering SNAP. Okay, symmetric, nonpolar, asymmetric, polar. So let's look at a couple of examples here. If I have HF, remember my lone pairs. Okay, My F is definitely going to be stronger. My electrons are going to be over here by the F, so it's going to be delta minus. My H is going to be delta plus. And so we would call this nonpolar. Or, sorry, we'd call this polar. All right? If I have something like this, my oxygen is my most electronegative, so it's going to be delta minus. We're just going to say everything else is delta plus. Yes, chlorine is also very electronegative. Oxygen wins, so we're just going to look at that for my for right now to keep everything simple. We're going to call this polar as well. Okay, so we're going to look at the symmetry. If I have something like B, Cl, 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 okay, this is symmetric. I can fold it in half there, I can fold it in half there, I can fold it in half there, right? And it always looks the same on the other side. So this is symmetric. So this is nonpolar. All right. So grab something that we've done before. Draw those molecules. Determine if they are polar or nonpolar. If they're by looking if they are symmetric or not symmetric.